Okay, let's start the class. Okay, today's topic is steam condensers. Today's topic is steam condensers. Okay, in this steam condensers, okay, let's see the introduction of the steam condensers. Okay, in steam power plants, in steam power plants, steam is generated at high pressure and temperature in a boiler and expanded in a prime mover to obtain work. After expansion, heat has to be rejected at lower temperature as it will lead to a higher efficiency. Higher efficiency. Okay, this is achieved by condensing the steam in a closed vessel called condenser. Okay, it is a major and very important equipment in a power plant. All modern power plants are of the condensing type and are more efficient than non-condensing ones. Okay, let's see the definition of this steam condensers. Okay, condenser is a device. Uh, Condenser is a device in which steam is condensed to water at a pressure less than atmosphere. Okay, pressure less than atmosphere. Okay, condensation is affected due to removal of latent heat from exhaust steam by using circulating cooling water. Thus, a condenser is basically a heat exchanger in which heat of the exhaust steam is transferred to the circulating water. Okay, once again I will explain you the what is this condenser. A condenser is a device in which steam is condensed to water at a pressure less than atmosphere. Condensation is affected due to removal of latent heat from exhaust steam by using circulating cooling water. Thus, a condenser is basically a heat exchanger in which heat of exhaust steam is transferred to the circulating water. Okay, what is the main function of this condenser? What is the main function of this condenser? Okay, condensers are used in steam power plants and in refrigeration system. Okay, to convert high pressure vapor refrigerant into liquid refrigerant. High pressure into liquid refrigerant. Okay, high pressure into liquid refrigerant. Okay, the main function of this condenser, the, uh, the, the, the the main function of this condenser and steam power plants are to decrease the exhaust pressure below the atmosphere, to decrease the exhaust pressure below the atmosphere, to provide hot feed water to the boiler, to provide hot feed water to the boiler. Okay, by use of condenser, nothing but by cooling the exhaust steam in a closed vessel, okay, to a lower temperature, the exhaust pressure can be maintained below atmosphere. Okay, this allows a higher pressure ratio for expansion. Okay, the efficiency as well as work output per kg steam increases substantially. Okay, the extra work available in case of condensed engines and turbines. Okay, you can see on my screen. You can see on my screen there is a okay, this is the extra work, okay, which we can see in a PV diagram. Okay, these are the without condensation and with condensation, and the boiler and the pressure, and in this there is a extra enthalpy drop. Okay, and you can see that the P2 is greater than the P atmosphere, and in here without work, there's a P2 is less than P atmosphere. Okay, this is enthalpy. Okay, right. Okay, in this nothing but the extra work available in case of condensed engines and turbines. Okay, the efficiency as well as the work output per kg of steam increases substantially. Okay, what are the advantages of this condensers? What are the advantages of this condensers? What are the advantages? Okay, higher pressure ratio provides larger enthalpy drop. Okay, in this higher pressure ratio, higher pressure ratio provides larger enthalpy drop. Okay, work output per kg of steam increases. Work output kg of steam increases. Thus, the specific steam consumption decreases. Okay, work output per kg of steam increases. Thus, the specific steam consumption decreases. Condensate can be reused as hot feed water. Condensate can be reused as hot feed water to the boiler as the feed water in as the feed water is hot. As the feed water is hot, it reduces the time of evaporation and hence fuel economy. Okay, it reduces the fuel economy. Condensate can be reused as hot feed water to the boiler as the feed water is hot. Okay, it reduces the time of evaporation and hence fuel economy. Okay, no feed water treatment is required. Okay, no feed water treatment is required. This reduces the cost of plant. Okay, these are the following advantages of this condenser. Okay, higher pressure ratio. Higher pressure ratio provides higher pressure ratio provides larger enthalpy drop. Higher pressure provides larger enthalpy drop. Okay, larger enthalpy drop. And work output per kg of steam increases. Work output kg of work output kg of steam increases. Work output kg of steam increases. Thus the specific steam consumption. Thus the specific. Okay, just a minute. Uh, thus the specific heat consumption decreases. Okay, condensate can be reused. Condensate can be reused as hot feed water to the boiler as the feed water is hot. It reduces the time of evaporation and hence fuel economy. Okay, no feed water treatment is required. This reduces the cost of plant. Okay, let's see the elements of condensating plant. Let's see the elements of condensating plant. Okay, in this you can see on my screen, these are the elements of condensating plant. Okay, in this, steam condensers operate at vacuum pressure as low as 0.05 bar absolute. Okay, 0. The pressure of 0.05 bars absolute. Okay, air leakages to condenser affect the performance. Air leakages to the condenser affects the performance. Okay, the air present in the condenser must be cooled to reduce the capacity of air pump. Okay, the following accessories are to required for required to provide for effective operation of condenser. Okay, in this you can see first this is the air pump. You can see here, this is the air pump. You can see this is the air pump. You can see this is the air pump. Okay, an air pump to remove air and other consoluble gases from the condenser. And next there's a condensating pump. You can see the pump. Condensating pump. Here is the pump. Here is the pump. You can see the pump. Okay, the condensate pump to remove the condensate from the condenser. Okay, to remove condensate from the condenser, to remove the condensate from the condenser. Next, there is a circulating water pump. You can see the circulating water pump. Okay, and there is a circulating water pump, nothing but the water pump. Okay, here we can see this is a condensate pump and this is the pump. Okay, there is a the circulating water pump for circulating the cooling water. Okay, here the cooling water is circulated by the water pump. And a hot well to receive the condensate. There is a hot well. You can see this is a hot well. Hot well to receive the condensate. Okay, cooling towers. You can see here the cooling towers. There are the cooling towers. Okay, cooling towers for cooling circulating water when there is only limited supply of water. Okay, cooling tower for cooling circulating water when there is only limited supply of water. Okay, these are the following accessories. Okay, I will tell you what the different types of accessories we are using in this condensating plant. Okay, an air pump to remove air and other condensable gases from the condenser. Next, condensate pump to remove the condensate from the condenser. And a circulating water pump for circulating the cooling water. A hot well to receive the condensate. Cooling water for cooling circulating water when there is only limited supply of water. These are the following what we say elements of this condenser. Okay, now we'll see what are the different types of uh, what are the different types of condensers. Nothing but the classification of condensers. What are the classification of condensers? Let's see the classification of condensers. Okay, in this steam condensers, simply we can say steam condensers are classified into two categories. That is jet condensers and surface condensers. They are classified into two types, that is jet condensers and surface condensers. Jet condensers, you can see on my screen, there's a jet condensers and surface condensers. First we'll learn about the jet condensers. Okay, what are jet condensers? Okay, jet condensers are used in small units where clean fresh water is available in plen- in plenty. Okay, more in available in plenty, available in plenty. Okay, in jet condensers water is in direct contact with exhaust stream. Okay, in jet condensers water is in direct contact with exhaust stream. Therefore jet condensers are also referred as direct contact type or mixed type condensers. Okay, direct contact type and type or mixed contact type. Okay, okay, the other name of this jet condensers. Okay, direct contact type or mixed type condensers. Okay, in jet condenser the steam is condensed by a spray of cold water. Okay, in this jet condensers steam is condensed by a spray of cold water injected into the injected into the injected into the condensers shell, and there is a complete mixing of steam and water. Okay, the condensed one, that is the hot water, gravitates to the extraction pump and is removed from the condenser Okay, this is the working of this jet condenser. Once again I will tell you what is jet condensers. Jet condensers are used in small units where clean fresh water is available in plenty. In jet condensers water is in direct contact with exhaust steam. Water is in direct contact with exhaust steam. Okay, water is direct contact with exhaust steam. Okay, jet condensers are also referred as that contact type or mixed type condensers. Okay, in jet condensers the steam is condensed by a spray of cold water injected into the condenser shell, and there is a complete mixing of steam and water. Okay, the condensate into the hot water gravitates to the extraction pump and is removed from the condenser. Okay, this is the working of this jet condenser. Okay, okay, what are the advantage of this jet condenser? What are the advantage of this jet condenser? Okay, let's see what the advantage of the jet condenser. Okay, 40 to 50, 10, 10. Mm, okay, just wait a minute, just wait a second. Okay, 20, 20 and more 30. 30 20 the 320 sir, 320 great. Okay, let's see what the advantage of this steam condensers. Okay, steam condensers as a result of effective mixing it requires less circulating cooling water. Okay, as a result of effective mixing, effective mixing it requires less circulating cooling water. Equipment is simple and occupies less space. Equipment is simple and occupies less space. Okay, this equipment is simple and occupies less space, and and maintenance is cheap. The following advantage of this what we say jet condenser. Okay, as a result of effective mixing it requires less circulating cooling water. Equipment is simple and occupies less space. Maintenance is cheap. Okay, when there are the advantage automatically there will be disadvantages. Okay, in this not suitable for high capacities, not suitable for higher capacities, and condensate cannot be reused as a hot feed water. Condensate cannot be reused as hot feed water. Air leakages are more, requires large air pump. Okay, in this air leakages are more and requires large air pump. Less vacuum is maintained. Okay, the following what we say uh, oh, disadvantage of this jet condensers. Okay, once again I'll tell you not suitable for high capacities. Okay, for larger capacities it is not suitable, and condensate cannot be reused as hot feed water. Okay, in this way we cannot use as a hot feed water. Air leakages are more. Okay, air leakages are more and requires large air pump less vacuum is maintained. Okay, less vacuum is maintained. Okay, next we'll discuss about the surface condenser. Let's discuss about the next type is the surface condenser. Okay, surface condensers are used in large plants. Surface condensers are used in large plants. In surface condenser, steam and water do not mix together. In surface condenser, steam and water, but in jet condensers, both will be mixing. In surface condenser, they will not mix together. Therefore, they are referred as indirect or non-mixing type condensers. They are also known as indirect or non-mixing type condensers. A surface condenser consists of a nest of tubes. It consists of a, you can see on my screen, it is a nest of, consists of consists of nest of tubes, consists of nest. Okay, you can say as bird has nest. Bird lives in a nest. In that way, it consists of a nest of tubes arranged in a certain pattern. Arranged in a certain pattern to give complete condensation of steam, to give complete condensation of, to give complete condensation of steam with minimum losses, exhaust steam from the turbine is passed over these tubes. Exhaust steam from the turbine is passed over these tubes through which cooling water is circulated, the steam is condensed by giving up its latent heat to cooling water circulated through the tubes. The cooling water is then passed to a cooling tower where it is cooled by a cooled air and is again recirculated through condenser. The condensated is pumped into a hot well from where it is supplied to boiler through a feed pump, through a feed pump. Okay, this is the working of this surface condenser. Okay, a surface condenser consists of a nest of tubes arranged in a certain pattern to give complete condensation of steam with minimum losses. Exhaust steam from the turbine is passed over these tubes through which cooling water is circulated. The steam is condensed by giving up its latent heat to cooling water circulated through the tubes. The cooling water is then passed to a cooling tower where it is cooled by a cooled air and is again recirculated through condenser. The condensate is pumped into a hot well from where it is supplied to boiler through a feed pump. Okay, this is the working of this surface condenser. So, what are the advantages of this surface condenser? What are the advantages of this surface condenser? Okay, first let's see the advantages. Okay, used for large capacity plants, large capacity plants. Okay, this is used for large capacity plants. High vacuum can be created, condensate is free from impurities. This condensate is free from impurities and can be reused as hot feed water into the boiler. Okay, can be reused as hot feed water in the boiler. Any type of water can be used as cooling medium. Okay, any water can be used as a cooling medium. Air leakage is comparatively less, hence less power is required to operate air pump. Okay, so the following advantages uh, in this pump. Okay. Mm, okay, These are the following advantages. Let's see the disadvantages in this. Okay, what are the disadvantages in this surface condenser? Design is complicated and costly. Design is complicated and costly, and high maintenance cost. High maintenance cost requires high maintenance cost, and occupies more space. Occupies more space. Requires more circulating water. Requires more circulating water. Okay, once again I will tell you the disadvantages. The design is complicated and costly. High maintenance cost, occupies more space, requires more circulating water. Okay, let's see the difference between this surface condenser and jet condenser. Let's see the difference between this uh, jet condenser and surface condenser. Okay, in this first we will see the difference between this. The main difference between these jet condensers and surface condensers are, first, this jet condenser is also known as direct type, contact type, and mixer type, whereas this is known as indirect type. Okay, indirect type. Remember, water and steam are direct contact. Water and steam are direct contact in jet condensers, whereas in surface condensers, water and steam are not in direct contact. Water and steam are not in direct contact. And next, less quantity of cooling water is required in jet condensers. Okay, less quantity of cooling water is required, whereas in the surface condenser requires large quantity of cooling water is required. Okay, large quantity of cooling water is required. And in jet condensers, low vacuum is maintained. Low vacuum is low vacuum is maintained, whereas in this surface condensers, high vacuum can be maintained. High vacuum can be maintained, and high vacuum can be maintained, and condensate can be reused water. Condensate cannot be reused water in jet condensers. It cannot be used, whereas in surface condensers, condensate can be reused as hot feed as hot feed water. Okay, this hot feed water can be used as hot feed water, whereas in jet condenser it cannot be used. And whereas in jet condenser, simple design has less maintenance cost. Simple design and less maintenance cost, whereas in surface condensers, complicated design, high maintenance cost. Complicated design and high maintenance cost. Okay, in jet condensers occupies less space. In jet condensers occupies less space, whereas in this surface condenser occupies more space. It occupies occupies more space. Okay, and jet gun is suitable only for small plants. It is suitable for small plants, whereas in surface gun is used for large plants. It is used for large plants. Okay, once again I will explain you the difference between these jet condensers and surface condensers. Okay, water and steam are in direct contact, whereas in this jet condensers and surface condensers, water and steam are not in direct contact. And that's why these jet condensers are known as a direct contact type, and this surface condensers are known as what we say, indirect contact. Nothing but the indirect type condensers, and they are known as direct type condensers, and they are known as indirect type surface condensers. Less quantity of cooling water is required. Less quantity of cooling water is required, whereas in the surface condensers, large quantity of cooling water is required. Large quantity of cooling water is required. In jet condensers, low vacuum is maintained. Low vacuum is maintained, whereas in surface condensers, high vacuum can be maintained. In this surface condensers, high vacuum can be maintained. In jet condensers, condensate cannot be reused water. Condensate cannot be reused water, whereas in the surface condensers, condensate can be reused as hot feed water. Condensate can be reused as hot feed water. Condensate can be reused as condensate can be reused as hot feed water. Okay, in jet condensers, simple design, less maintenance cost. Simple design and less maintenance cost. Simple design and less maintenance cost. When surface condensers, complicated design and high maintenance cost. Complicated design and high maintenance cost. Complicated design and high maintenance cost. In jet condensers, occupies less space, and surface condensers occupies more space. Jet condensers are suitable only for small plants, and surface condensers are used for large plants. Okay, now we'll discuss about the types of jet condensers. Okay, we'll discuss about the types of jet condensers. Okay, in this type of jet condensers, we have low level jet condenser, high level jet condenser, and ejector type jet condenser. Low level, high level, and ejector type jet condensers. Okay, now let's see the uh, low level. First, we'll see the low level. That's the ejector type. First, we'll see the low level parallel flow jet condenser. Okay, okay. First, we'll see low level. Okay, low level jet condensers will be. We'll see low level jet condensers. Okay, in this low level jet condenser consists a cylindrical shell with its lower end connected to a pump by a tailpipe. Depending on the direction of steam and water flow, low level jet condenser are classified into parallel flow jet condensers and counter flow jet condensers. Okay, first we'll learn about the parallel flow jet condensers. First we'll learn the parallel flow jet condensers. Okay, in parallel flow jet condenser, cooling water and the exhaust steam flow in the same direction through the shell. Okay, exhaust steam from the engine or turbine enters at the top. The cooling water is sprayed into the steam at the top of the shell. Both the steam and cooling water are mixed, which results in the condensation of the steam. The mixture, nothing but the condensate and water, is extracted by a pump at the bottom and discharged to the hot well. Okay, okay. It may be used as a boiler feed water if the cooling water is free from impurities. Okay, this is a way of low level parallel jet condenser. A parallel flow jet condenser, you can see in the figure. Okay, it does not require pump to lift water because it flows upward automatically due to the pressure difference. It is provided with a dry air pump to extract air and baffle plates inside the shell to facilitate through mixing of through mixing of steam and water through mixing of steam and water. Okay, this is the working of this low level. low level parallel. Hello. In this is the working of this parallel flow jet condenser. Parallel flow jet condenser. Okay. Hello. Hello. ఎవరు కావాలి? ఎవరు కావాలి? మేకలోడు. Hello. This is the low level parallel flow jet condenser. In parallel flow jet condenser, cooling water and exhaust steam flow in the same direction through the shell. Exhaust steam from the engine or turbine enters at the top. The cooling water is sprayed into the steam at the top of the shell. Both the steam and cooling water are mixed, which results in the condensation of the steam. The mixture, condensate and water, is extracted by a pump at the bottom and discharged to the hot well. It may be used as a boiler feed water if the cooling water is free from impurities. Uh, uh, okay, a parallel flow jet condenser. It does not require pump to lift water because it flows upward automatically due to pressure difference. It is provided with a dry air pump to extract air and baffle plates inside the shell to facilitate mixing of steam and steam and water through steam and water. Okay. Steam and water. Okay, now let's see the low level contour flow jet condenser. It consists of a cooling pond, it consists of cooling water, and consists of a perforated tray, and consists of a perforated plate, steam condensate, and a condensate pump, and the hot well. Okay, in counter flow jet condenser, the water and steam in counterflow condenser, the water and steam flow in opposite direction through the shell. In this case, exhaust steam from the engine or turbine enters at the bottom of the condenser and rise upward while the cooling water enters at top and flows downward. Cooling water is sprayed in the form of jets through a series of perforated trays. The steam, while rising up, comes in direct contact with water and rapid condensation takes place. Non-condensable air is sucked by an air pump from the top. The mixture of condensate and water is collected at the bottom and discharged to hot well by means of condensate pump. Okay, this is the working of this low level. Counter flow jet condenser. Okay, in a counter flow jet condenser, the water and steam flow in opposite direction to the shell. In this case, exhaust steam from engine or turbine enters at the bottom of the condenser and rises upward while the cooling water enters at the top and flows downwards. Cooling water is sprayed in the form of jets through a series of perforated trays. The steam, while rising up rising up comes in direct contact with water and rapid condensation takes place. Non-condensable air is sucked by an air pump by an air pump by an air pump from the top. The mixture of condensate and water is collected at the bottom and discharged to hot well by means of condensate pump. So this is the working of this counterflow jet condenser. Now let's see the high level uh, I have said the types of jet condenser. There's low level jet condenser, and next is the high level jet condenser. Okay, this is the high level jet condenser. Okay, consists of cooling pond, feed pump, cooling water. It consists of it consists of cooling water. It consists of condensator shell and the baffle plates, steam, and the boiler feed water. Okay, right. Okay, this height is about 10.36 meter. Okay, right. Let's see how it works. Okay, let's see how it works. Okay, first, high level or barometric jet condenser is similar to low level con contra flow jet condenser, but the condenser shell is situated at a height of 10.6 meter. Okay, I have said this height is situated 10.6 meter from the level of hot well, and accumulated condensate will drain by itself without the aid of condensate pump. This is a high level jet condenser. Okay, the exhaust steam enters at the bottom while the cooling water is pumped in at the top. Thus, the counterflow is maintained and steam mixed with water gets condensed. The mixture of condensate and cooling water, the mixture of condensate and cooling water flows down to the hot well. The air is extracted from the top with the help of dry air pump. Okay, this is the working of this high level jet condenser. Okay, once again, I will tell you how is the high level jet condenser works. Okay, high level or barometric jet condenser is similar to low level contraflow jet condenser, but the condenser shell is situated at an height of 10.36 meter from the level of hot well, and accumulated condensate will drain by itself without the aid of condensate pump. High level jet condenser, the exhaust steam enters at the bottom while the cooling water is pumped in at the top. Thus, the counterflow is maintained and steam mixed with water gets condensed. The mixture of condensate and cooling water flows down to the hot well. The air is extracted from the top with the help of dry air pump. Okay, this is the working of this high level. This is the working of this high level jet condenser. Okay, what are the advantage of this high level jet condenser? Does not require condensate pump. Does not require condensate pump. Okay, condensate can be reused as feed water if the cooling water is free from impurities. Okay, the cooling water is free from impurities. Okay, what are the disadvantages? Requires circulating pump to lift cooling water to the top of the condenser. Okay, there is a requires of circulating pump. Okay, once again, I will tell you what are the advantages and disadvantages. So, what are the advantages? It does not require condensating pump. It does not require condensating pump. Condensate can be reused as feed water if cooling water is free from impurities. So, what are the disadvantages? Requires circulating pump to lift cooling water to the top of condenser. Okay, this is the working of this high level. We already have said we have three types of jet condensers: low level, high level, and third one is the ejector type. Third one is the ejector type. Okay, this is the ejector type jet condenser. Okay, let's see how it works. Okay, let's see how it works. Okay, okay, an ejector type jet condenser, okay, it consists of cooling water. You can see here it consists of cooling water, and it consists of a nozzle which increases the pressure, and it consists of a non-return valve. Non-return valve is a valve. Once it will enter, it does not send back. This is a non-return valve, and the steam inlet, and the hollow truncated cones. There's a hollow truncated cones, and this is a condensate and cooling water. This is a condensate and cooling water. This is a condensate cooling water. Okay, let's see how it works. Okay, it is suitable for moderate vacuum. It is suitable for moderate vacuum. In these condensers, cooling water is discharged through a series of convergent nozzles with which creates partial vacuum, and a mixture of air and exhaust steam is drawn into the condenser through a non-return valve. The steam is thoroughly mixed with cooling water in hollow truncated cones and get condensed. The vacuum is further increased by condensation of steam. The mixture of condensate, air, and cooling water is discharged through divergent cone into the hot well. In the absence of cooling water supply, water from hot well may rush into the engine or turbine. Okay, this is prevented by providing a non-return valve in the steam pipeline. Okay, this is the working of this ejector type uh, jet condenser. Okay, once again I will tell you it is suitable for moderate vacuum. In this condenser, cooling water is discharged through a series of convergent nozzle which creates partial vacuum, and a mixture of air and exhaust steam is drawn into the condenser through a non-return valve. The steam is thoroughly mixed with cooling water in hollow truncated cones and gets condensed. The vacuum is further increased by condensation of steam. The mixture of condensate air and cooling water is discharged through divergent cone into hot well. In absence of cooling water supply, water from hot well may rush into the engine or turbine. This is prevented by providing an non-return valve in the steam pipeline. Okay, this is the working of this ejector type. Okay, in this class we have discussed about them. Till now we have discussed about the steam condensers. What is condenser? What are the functions of steam condenser? And also we have discussed about the elements of condensating plant, and we also discussed about the classification of condensers. In this classification of condensers, we have discussed about the jet condenser and surface condenser, and also we have discussed about the advantages and disadvantages, and also we have compared the both jet condenser and the surface condenser. And in this jet condenser, we have discussed about the different types, that is low level, high level, and ejector type. And also we have discussed in this low level, we have discussed two types of condenser. There is parallel flow and counterflow type. And also in this we have discussed the high level, and also in this high level we have discussed the advantages, disadvantages, and also at the end we have discussed about the ejector type condenser. Okay, these are the following jet condensers. In the next class we'll discuss about the surface condensers. Okay, what are the types of surface condensers, uh, what are the types of surface condensers, and what are the advantages and what are the disadvantages, we'll discuss in the next class. Okay, okay, thank you very much. Okay, we'll discuss in the remaining topics, we will discuss in the next class. Thank you very much.